Hello friends, today we are going to learn the concept of curve tracing. Particularly we will discuss here the Cartesian form of curve. At the end of this topic, you will be able to explain the procedure to trace a curve in Cartesian form, describe the symmetry of a curve in Cartesian form, and explain the concept of asymptote. The knowledge of curve tracing is to avoid the labor of plotting a large number of points. It is helpful in finding the length of curve, area, volume and surface area. In double and triple integration, the limits of integration can be easily found on tracing the curve roughly. This is the procedure. This illustrates the procedure how to trace a curve given into the form of Cartesian. Step number 1, check for the symmetry of a curve. Check out whether the curve is symmetrical about the x-axis, y-axis or other straight line. Yeah, about origin. Step number 2, check curve passes through origin or not. And if curve passes through origin, then find the equation of tangent at origin. Step number 3, find the points of intersection with axis. Step number 4, find the reason of absence of a curve. Step number 5, find the equation of asymptote to a curve. Step number 6, find the special points on the curve. Let's move these steps one by one, in detail. Check for symmetry of a curve. This is the step number 1. So symmetry about x-axis. If we want to check whether the given curve is symmetrical about x-axis or not, so very simple. In whole equation, check out the power of y. If y is there and with the even power, so we can say that this curve is symmetrical about x-axis. So in this example, in the left hand side, y square is equal to 4x, equation of parabola, where y is present over there and with the power 2. So this curve is symmetrical about x-axis. So we can see this is the x-axis and this is the curve. So we can conclude that this curve is symmetrical about x-axis. So, in the right hand side, the same other example is there. Y square is equal to minus 4, another parabola. So this is also symmetrical about x-axis. This is the curve. Next symmetry is symmetry about y-axis. So here x should have even powers within the given curve, within the given equation of the curve. So this is the equation of the curve, x square is equal to 4ay. This is y-axis, and if we trace this curve, so this curve look like this. So this curve is symmetrical about y-axis. Similarly, this is the another example. So this is y-axis and this is the curve. So this curve is symmetrical about y-axis. So also we can discuss the symmetry about y is equal to x, slanting line. So by interchanging x and y, if that equation remains same, then the curve is symmetrical about the line y is equal to x. So for that purpose, we consider here the example x cube plus y cube is equal to 3axy. This is the line y is equal to x, and this is the curve. So this curve is symmetrical about the line y is equal to x. We can check out whether the curve is symmetrical about in the opposite quadrants. So very simple way, when x and y are replaced by minus x and minus y, and if the equation remains unchanged, so we conclude that the given curve is symmetrical in opposite quadrants. So here the one example. So this is the summary, how to check out, how to memorize the results for symmetry. So in this table in the left hand side, this is the symmetric about of y-axis, x-axis, about the line y is equal to x. And on the right hand side, we have the condition under what that curve is symmetrical about, satisfies the condition. Next step is check out whether that curve passes through origin or not and find the tangents. So if that equation of the curve does not contain any constant term, so we can conclude that the curve passes through origin. And if that curve passes through origin, then find the tangent or tangents at that origin to investigate the nature of multiple points such as node, cos. So we will discuss this node and cos in the next slide. So the equation of tangent at the origin can be obtained by equating to 0 the lowest degree term in the equation of the curve. So this slide illustrates the concept of node. This point P is a node where, so we can draw the tangent here. Similarly, we can draw the tangent here. So these are the two different tangents coinciding at the point P. So therefore this point P is known as node. In this case, at the point P, we have two tangents. So these two tangents are coincident. So therefore this point is known as cos. For example, let us consider here one example. This is the one example of curve given. So in this example, in this case constant term is absent, therefore this curve passes through origin. And to find the tangents at this origin, so we consider the lowest degree term into this equation. This is the term with degree 3, this is the term with degree 3 with this, and this is the only one term with the degree 2. So with the degree 2, so this is the term, lowest degree term, so we consider it equate to 0. So we got y is equal to 0 and 0. So this is the double point, and this is nothing but the equation of x-axis, and therefore x-axis is the tangent at origin. Next example, we can see here that the constant term is absent, therefore this curve passes through origin, and the lowest degree term is ax square minus ay square equate to 0. So we found that y square is equal to x square. So y is equal to x and y is equal to minus x. These are the tangents at the origin which are real and different, therefore origin is a node here. So step number 3, find the points of intersection with the axis. So to find the point of intersection with x-axis, put y is equal to 0 into the given equation of the curve. And similarly, to find the point of intersection with y-axis, put x is equal to 0 into the given equation of the curve. For this purpose, consider this simple example. So in this example, put y is equal to 0. So we got that x is equal to plus minus a. So these are the 2 points where this curve meets the x-axis. Similarly, you can find out the point of intersection with y-axis by putting x is equal to 0 into the given equation. So step number 4, find the reason of absence of a curve. So we can find the reason of absence of the curve. If the value of y is imaginary for certain value of x, then the curve does not exist for such values. For example number 1, y square is equal to 4x. For negative value of x and y, for negative value of x, y becomes imaginary, so there is no curve in second and third quadrant. Similarly, in example number 2, we can observe that for y greater than 2a, x becomes imaginary, so there is no curve in second and third quadrant. So for negative values of y, x is imaginary, so there is no curve in third and fourth quadrant. Step number 5, find the equation of asymptote to a curve. So there are 3 types of asymptotes: parallel to x-axis, parallel to y-axis, and oblique asymptotes. In a later we will discuss the oblique asymptote in the next class. So here we discuss the parallel to x-axis. So how to find the asymptote parallel to x-axis? So that can be obtained by equating to 0 the coefficient of the highest power of x. So this is the example. In this example, if we consider the coefficient of the highest power of x equal to 0, so we obtain that y minus 4 is equal to 0 is the asymptote parallel to the x-axis, that is y is equal to 4. So this is the note. By this note we can find out the asymptote parallel to x-axis. Similarly, we can find out the asymptote to parallel to y-axis. And these are the some useful remarks these are useful in order to trace a given curve. And step number 6, if possible, prepare a table for certain values of x and y and dy by dx, which helps us to draw a rough shape of the curve. Now we consider one example here. So trace the curve y square into 2a minus x is equal to x cube. This is the curve given in Cartesian form. So we consider this curve into this form. Equation contains only even powers of y, therefore it is symmetrical about x-axis. This is our first conclusion. So we check the symmetry. Now we check out whether that curve passes through origin or not. So equation does not contain any constant term, therefore it passes through origin. Tangent at origin. So let us try to find out the tangents at origin, and that can be obtained by equating the lowest degree term equal to 0. So we got y is equal to 0 and y is equal to 0, that is a double point. And this are the two at this origin there are 2 tangents and they are coincident, therefore that origin is known as cusp. Multiple point is cusp. Equation of asymptote as x tends to 2a and y becomes infinite, therefore x is equal to 2a is an asymptote, as we discussed earlier. Reason of absence of the curve. Now in the equation y square becomes negative on putting x is greater than 2a or x is less than 0, and therefore the curve does not exist for x is less than 0 and x is greater than 2a. So with the help of all this point, first draw the x-axis and y-axis, plot these some points. So this is the asymptote, x is equal to 2a. Now this is the table, step number 6. With the help of the given equation of the curve, we can plot, you can draw this table, and these are the points. This is the reason of absence. X is less than 0, there is no curve. X is greater than 2a, there is no curve. And if we join all these points in the first quadrant in between y-axis and the asymptote, so we observe that this is the curve. So this is the tangent at origin. So this point is origin. So these are the point and this origin is the cos. Now we summarize all the results. So step number 1 is check for the symmetry. Step number 2, check out whether that curve passes through origin or not. And if that passes through origin, then find out the equation of tangents. Step number 3, find the points of intersection with axis. Step number 4, find the reason of absence of a curve. Find the equation of the asymptotes to the curve and find the special points on that curve. So this is the summary, references. Thank you very much.